In this video, we are going to study how to find shortest distance between two straight lines in space. We have to consider two types of straight lines in space. In the first type, there is one straight line L1 in the top plane A, B, C, D of this cuboid and another straight line L2 in the bottom plane EFGO of this cuboid. Now since top face ABCD is parallel to bottom face EFGO of this cuboid, the lines contained in them L1 and L2 will also be parallel, and the distance between L1 and L2 will be the length of perpendicular between L1 and L2 that we denote by D. In another type, we will consider one straight line L1 in top plane ABCD of this cuboid and another straight line L2 in the side plane AEFB of this cuboid. Now, the top plane ABCD is not parallel to the side plane AEFB. Therefore, the lines L1 and L2 contained in them will also not be parallel. In fact, they will be non-parallel and non-intersecting lines or skew lines, and distance between them, length of the perpendicular D between them. So the shortest distance D between lines L1 and L2 will be the length of perpendicular between L1 and L2. Let us talk more about this. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Now we will see how to find distance between two parallel lines in space. For that, let us consider this figure in which the top plane ABCD is parallel to the bottom plane EFGO in any cuboid. So any line L1 whose vector equation is r bar equals a bar plus s b bar, and this line L2 whose vector equation is r bar equals a bar plus t b bar will be parallel to each other. These lines are parallel can be ascertained by the fact that they are parallel to the same vector b bar parallel to them. Let A be any point on line whose position vector is a bar and B be any point on L2 whose position vector is c bar. Now perpendicular from point A on line B is AD, which is length of perpendicular D between these two parallel lines. Let us join A and B so that vector AB makes angle theta with line L2, which also means acute angle between vector AB bar and vector B bar is theta, and we have sin theta equals mod AB bar cross B bar upon mod AB bar dot mod B bar by definition of cross product. We name this 1. We also have in right triangle ADB, sin theta is AD upon AB, that is length of perpendicular D upon mod AB bar. We name this 2. Now equating 1 and 2, we write D upon mod AB bar equals mod AB bar cross B bar upon mod AB bar dot mod B bar. Cancelling mod AB bar from both sides, this will be mod AB bar cross B bar upon mod B bar. So finally we get this length of perpendicular D equals mod, writing AB bar as C bar minus A bar cross B bar upon mod B bar. Obviously mod B bar is non-zero. So this relationship gives us distance between two parallel lines in space. We have to find distance between the lines L1 and L2, where line L1 is and L2 is. Here this vector is A bar, this vector is C bar, and these two vectors a single vector B bar, and it is parallel to both lines L1 and L2, and that is also the reason why L1 is parallel to L2. Distance between L1 and L2 is length of perpendicular D given by mod C bar minus A bar cross B bar upon mod B bar. Now we will find these quantities. So first we find C bar minus A bar, 3 minus 1, 2 I cap, 3 minus 2, 1 j cap, minus 5u plus 4, minus 1 k cap, and mod B bar will be square root 2 square 4 plus 3 square 9 plus 6 square 36 square root 49 7. Next we have to find C bar minus A bar cross B bar, that will be determinant I j k 2 1 minus 1 2 3 6 9 I cap minus 14 j cap plus 4 k cap. Next we find mod C bar minus A bar cross B bar, which will be square root this 9 square 81 plus this minus 14 square 196 plus this 4 square 16, which will be square root 293. Now for a distance D, we have mod C bar minus A bar cross B bar square root 293 upon mod B bar, which is 7. So square root 293 upon 7 units will be the distance between parallel lines L1 and L2. Before we proceed with finding shortest distance between two skew lines, let us understand what is meant by projection of one vector A bar on another vector B bar. Suppose we have vector A bar and another vector B bar, then projection of A bar on B bar will be A bar dot unit vector in the direction of B bar, which means A bar dot B cap or A bar dot B bar upon mod B bar, which being a dot product will be a scalar or a number. We will see how to find shortest distance between two skew lines from this figure. Skew lines are two non-parallel, non-intersecting lines, such as this line L1 R bar equals A bar plus S B bar belonging to the side plane AEFB of this cuboid, and line L2 R bar equals C bar plus T D bar belonging to the top plane ABCD of this cuboid. We consider shortest distance between two skew lines because from the shortest distance away the distance diverges to infinity. Now we have line L1 and L2 are skew lines can also be understood from the fact that line L1 is parallel to vector B bar and line L2 is parallel to vector D bar, and since B bar is not parallel to D bar, the lines are skew lines. Now L1 is parallel B bar and L2 is parallel to D bar, which implies that cross product of B bar and D bar is perpendicular to L1 and L2. We name this 1. Now let SD is perpendicular to both L1 and L2. Therefore, vector SD is parallel to cross product B bar and D bar, and a unit vector in direction of SD bar will be B bar cross D bar upon mod B bar cross D bar. Now, shortest distance between L1 and L2, delta, is modulus of vector SD bar, which is the absolute value projection of vector AC bar on vector SD bar. Now, if we take point A on line L, whose position vector is A bar, and point C on L2, whose position vector is C bar, then this vector AC bar is going to be vector C bar minus A bar. Now what is the absolute value of projection of AC bar on SD bar? It is nothing but modulus of dot product of AC bar and the unit vector in the direction of SD bar as found out here. So delta is mod C bar minus A bar dot B bar cross D bar upon mod B bar cross D bar. So the formula for shortest distance between skew lines L1 and L2, delta is modulus C bar minus A bar dot B bar cross D bar upon mod B bar cross D bar. We have to find shortest distance between two skew lines, line L1 and line L2. We have A bar equals this I cap plus J cap, C bar equals this 2 I cap plus J cap minus K cap, B bar equals 2 I cap minus J cap plus K cap, and D bar equals 3 I cap minus 5 J cap plus 2 K cap. Here we see that B bar is not a scalar multiple of A bar, therefore L1 and L2 are skew lines, and we have to find shortest distance D between them, because away from the shortest distance between them diverges to infinity, and we have deduced a formula for this shortest distance D as mod C bar minus A bar dot B bar cross D bar upon mod P bar cross D bar. So first C bar minus A bar 2 minus 1 I cap minus 1 minus 0 minus K cap. Next B bar cross D bar is determinant ijk 2 minus 1 1 3 minus 5 2, which will be 3 I cap minus J cap minus 7 K cap. Next we have to find mod B bar cross D bar, that will be square root this 3 square 9 plus minus 1 square 1 plus minus 7 square 49 square root 59. One more quantity we need to find out is mod C bar minus A bar dot B bar cross D bar, that will be mod I cap minus K cap dot 3 I cap minus J cap minus 7 K cap, that will be mod 1 into 3 3 0 into minus 1 0 minus 1 into minus 7 plus 7 10. Now we substitute the values to find the shortest distance D here. The numerator we got is this 10 upon denominator we got is root 59. So 10 upon root 59 is the shortest distance D between skew lines L1 and L2. There is one correction here. This is not A bar but D bar, and the sentence is P bar is not a scalar multiple of D bar. We are going to show two lines L1 and L2 intersect each other. We will compare these equations with r bar equals a bar plus s b bar and r bar equals c bar plus t d bar. Point A on line L1 is x1 y1 z1, that is 2 6 3, and point B x2 y2 z2 on line L2 is 0 2 minus 3. DRs of a parallel vector to line L1 are b1 b2 b3 2 3 4, and DRs of parallel vector d bar to line L2 d1 d2 d3 are 1 2 3. L1 and L2 will intersect if determinant x2 minus x1 y2 minus y1 z2 minus z1 b1 b2 b3 d1 d2 d3 is 0 if we evaluate this determinant 0 minus 2 minus 2 2 minus 6 minus 4 minus 3 minus 3 minus 6 2 3 4 1 2 3. It works out to be minus 2 into 1 plus 4 into 2 minus 6 into 1 0, which proves that L1 and L2 will intersect. This can also be shown in another way. From given equations, we have a bar equals 2i cap plus 6j cap plus 3k cap, and c bar equals 2j cap minus 3k cap. So from this, c bar minus a bar will be 0 minus 2 minus 2i cap 2 minus 6 minus 4j cap minus 3 minus 3 minus 6k cap, and b bar is 2i cap plus 3j cap plus 4k cap, and d bar is I cap plus 2j cap plus 3k cap. Their cross product will be determinant ijk 2 3 4 1 2 3. That will be 9 minus 8 1 I cap minus 6 minus 4 2j cap plus 4 minus 3 1 k cap. Now we have distance d between two lines mod c bar minus a bar dot b bar cross d bar upon mod b bar cross d bar. If the numerator is 0, distance between two lines will be 0 and the lines will intersect each other. So the numerator here mod c bar minus a bar dot product b bar cross d bar will be minus 2 into 1 minus 2 minus 4 into minus 2 plus 8 minus 6 into 1 minus 6. 8 minus 8 will be 0. Since the numerator, this one, is 0, proves that L1 and L2 intersect each other. Two lines in space are given, and in Cartesian or symmetric form, a point B on this line is 3 0 minus 2, and vector d bar parallel to it is 2i cap minus j cap plus 2k cap. So vector equation in parametric form of this line will be r bar equals from point B 3i cap minus 2k cap plus parameter s d bar. Now comparing equation 1 and equation 2, we have b bar equals, which is minus equals minus d bar. Now since b bar is scalar multiple of d bar, implies that line 1 and line 2 are parallel. Now we have c bar and a bar. So c bar minus a bar will be, which is I cap minus 3j cap minus 6k cap, and the shortest distance between them d is mod c bar minus a bar cross b bar upon mod b bar. Now c bar minus a bar, which is, that is, now we have to find, that will be determinant 1 minus 3 minus 6 and minus 2 1 minus 2, which will be 12 I cap plus 14 j cap minus 5 k cap, and mod of c bar minus a bar cross b bar is square root 12 square plus 14 square plus minus 5 square, square root 365, and mod b bar is square root minus 2 square plus 1 square plus minus 2 square root 9, 3. So the shortest distance between these parallel lines will be square root 365 upon 3. We have to find coordinates of foot of the perpendicular Q from the point P minus 1, 2, 3 to the line r bar equals I cap minus 4j cap plus 3k cap plus parameter t into 2I cap plus 3j cap plus k cap. This line is parallel to this vector b bar. Coordinates of point Q will be of the type this 2t plus this 1, this 3t minus this 4, and this t plus this 3. Now from the coordinates of point P and Q, vector PQ will be this 2t plus 1 minus this minus 1, that is plus 1 I cap, plus this 3t minus 4 minus this 2 j cap, plus this t plus 3 minus this 3 k cap. That will be 2t plus 2 I cap plus 3t minus 6 j cap plus t k cap. Now vector PQ bar is perpendicular to this vector B bar, so their dot product will be 0. Therefore 2I cap plus 3j cap plus k cap, which is B bar dot 2t plus 2 I cap plus 3t minus 6 j cap plus t k cap will be 0. That means 2 into 2t plus 2 plus 3 into 3t minus 6 plus 1 into t will be 0. That gives 4t plus 9t plus t plus 4 minus 18 equals 0. 14t equals 14. So t equals 1. Substituting value of t here, coordinates of foot of perpendicular Q will be 2 into 1 plus 1, 3, 3 into 1 minus 4, minus 1, 1 plus 3, 4. And this vector PQ bar will be 4I cap minus 3j cap plus k cap, and length of perpendicular PQ bar will be mod PQ bar square root of 4 square 16 plus minus 3 square 9 plus 1 square 1 square root 26 units. We have to show that whether lines L1, L2 are skew lines, and if yes, we have to find shortest distance d between them. We rewrite L1 as dividing throughout by minus 12. That will be x plus 1 upon minus 12, y minus 0 upon minus 6 equals z minus 0 upon 1. So in this case, vector A bar is minus I cap and B bar is minus 12 I cap minus 6 j cap plus k cap. L2 can be rewritten as dividing throughout by 6 z minus 1 upon 1, which will be x minus 0 upon 6. So C bar will be minus 2 j cap plus k cap, and parallel vector D bar will be 6 I cap plus 6 j cap plus k cap. Now since B bar and D bar are not scalar multiples of each other, it implies that lines L1 and L2 are skew lines. Now to find shortest distance d between them by the formula C bar minus D bar dot B bar cross D bar upon mod B bar cross D bar, we have to find C bar minus A bar from here minus 2 j cap plus k cap minus I cap, that is I cap minus 2j cap plus k cap. There is one correction. This should be minus a bar and not minus d bar. Now b bar cross d bar is I cap j cap k cap minus 12 minus 6 1 6 6 1, which is, that will be, or 6 times minus 2 I cap plus 3 j cap minus 6 k cap, and mod b bar cross d bar will be 6 times square root this minus 2 square 4 plus this 3 square 9 plus this minus 6 square 36, that will be 6 into square root of 49, 6 into 7 42. We write this c bar minus a bar here. Now this dot product will be this vector dot this vector, which will be 6 into 1 into minus 2 minus 2 minus 2 into 3 minus 6 1 into minus 6 minus 6 minus 84. Now shortest distance between L1 and L2, D, is mod minus 84 upon this 42 2. We have to show that lines L1 and L2 y minus 2 equals 0 intersect, and further we have to find the point of intersection. First we will rewrite L1 and L2 equals z minus 1 upon 0 and y minus 2 upon 0 equals z minus 1 upon 3. Here given point on the line is x1 y1 z1 equals this 3, this 3, this 1, and point x2 y2 z2 on second line L2 is this 6, this 2, and this 1. DRs of vector parallel to L1 are b1 b2 b3, which are 3 minus 1 0, and DRs of the vector parallel to second line L2 are d1 d2 d3 are 2 0 3. We know that lines L1 and L2 will intersect if determinant x2 minus x1 y2 minus y1 z2 minus z1 b1 b2 b3 d1 d2 d3 is 0. Now 6 minus 3 3, 2 minus 3 minus 1 1 minus 1 0, 3 minus 1 0 2 0 3. We know that when two rows in a determinant are identical, value of the determinant is 0, which implies L1 and L2 intersect. This can also be shown in another way from the formula of shortest distance between two skew lines, which is D equals mod C bar minus A bar dot P bar cross D bar upon mod P bar cross D bar. In this formula, if the numerator is 0, distance D will be 0. So A bar is 3 I cap plus 3 j cap plus k cap, and C bar is 6 I cap plus 2 j cap plus k cap. So C bar minus A bar will be 6 minus 3 3 I cap 2 minus 3 minus j cap 1 minus 1 0 k cap. B bar is 3 I cap minus j cap plus 0 k cap, and D bar 2 I cap plus 0 j cap plus 3 k cap, and B bar cross D bar will be 3 minus 1 0 and 2 0 3. That will be I into minus 3 minus j into 9 plus k cap into 2 minus 3 I cap minus 9 j cap plus 2 k cap, and dot product C bar minus A bar dot B bar cross D bar will be this 3 I cap minus j cap dot this minus 3 I cap minus 9 j cap plus 2 k cap, which will be, we write it here, 3 into minus 3 minus 9 plus minus 1 minus 9 plus 9, and 2 into 0 plus 0, so that will be 0. This also proves L1 and L2 intersect. Next we find the point of intersection. For L1 this will be S, and for L2 this will be T, so that point of intersection on L1 will be of the type 3s plus 3 minus s plus 3 and 1, and that on L2 will be of the type 2t plus 6, 2 and 3t plus 1. Now these 2 points being the same, we can equate their corresponding coordinates. So 3s plus 3 will be 2t plus 6, that gives 3s minus 2t equals 3. Similarly, minus s plus 3 will be equal to 2, that gives s equals 1. Using this in this equation, it gives 3 minus 2t equals 3. Cancelling 3, we get t equals 0. The coordinates of point of intersection will be using t equals 0 here, this 6, 2 and this 1. We have to find equation of a line L which passes through a point minus 1, 2, 1 and which is parallel to another line L1 whose equation is, and hence we have to find shortest distance d between them. Line L passes through point A, therefore A bar is minus I cap plus 2j cap plus k cap, and for line L1 parallel vector p bar is, it is given L parallel L1 parallel b bar, therefore required equation of L will be r bar equals a bar plus t b bar. That is, now from equation of L1 bar we get c bar equals this 2i cap plus 3j cap minus k cap. For shortest distance we shall need c bar minus a bar, which will be 2 plus 1 3i cap plus 3 minus 2 plus j cap minus 1 minus 1 minus 2 k cap, and cross product c bar minus a bar and b bar will be determinant ijk 3 1 minus 2 and 1 minus 2 1, which is minus 3 I cap minus 5 j cap minus 7 k cap, and mod c bar minus a bar will be square root minus 3 square 9 plus minus 5 square 25 plus minus 7 square 49 root 83, and mod b bar will be square root of 1 square 1 plus minus 2 square 4 plus 1 square 1 root 6. Now shortest distance d is, putting the values, this root 83 upon this root 6. Please note one correction. This is not mod c bar minus a bar, but mod c bar minus a bar cross b bar, which is root 83. We have to find foot of the perpendicular, say Q, from a point P 542 to the line x plus 1 upon 2 equals y minus 3 upon 3 equals z minus 1 upon minus 1. We will assume each of these ratios to be t, so that coordinates of any point such as Q on this line will be of the type 2t minus 1, 3t plus 3 minus t plus 1. So vector pq bar will be 2t minus 1 minus 5 I cap plus 3t plus 3 minus 4 j cap plus 1 minus t minus 2 k cap, which is 2t minus 6 I cap plus 3t minus 1 j cap plus minus t minus 1 k cap. Now vector parallel to this line b bar is this 2 I cap plus this 3 j cap minus k cap, and we know that pq bar is perpendicular b bar, which implies pq bar dot p bar is 0. That gives this 2 into 2t minus 6 plus this 3 into 3t minus 1 minus this 1 into minus t minus 1 equals 0. So 4t plus 9t plus t minus 12 minus 3 plus 1 equals 0. 14t equals 14. T equals 1. Therefore, coordinates of point Q will be 2 into 1 minus 1, 1, 3 into 1 plus 3, 6, minus 1 plus 1, 0. So, foot of the perpendicular PQ is 160. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.